everybody. Okay, so in this video we're going to review the cross product. So let's say you have these two vectors in space, u and v. And let's say you already know the magnitude of u, you already know the magnitude of v, and you know the angle between them. So one way to do the cross product is the magnitude of the first one times the magnitude of the second one times sine of the angle between them. This is still just a scalar, but the cross product gives you a vector. It's also called the vector product. So vector cross vector gives you another vector. So we need a unit vector to denote that direction, and this is according to the right-hand rule. Right, so right-hand rule is like, if you look at this picture, but if you look in my video, like let's say you go u cross v, and then which way your thumb is pointing, right? So you see how this forms a 3D coordinate system. So like the first vector cross the second vector, and your thumb is pointing in the direction of that cross product. You see this three-dimensional coordinate system. Okay, but then let's say if you know both vectors already in terms of their components, then another way to do the cross product is this determinant, like this. So if you already have them in component form, so how do you compute this determinant? Two different ways, up to you, whichever way you think is easier, do that way. So this first method, Saurus's scheme, right? So first you set up this determinant. Here's the first vector cross the second vector, broken down into components. So to compute this determinant, repeat the first two columns like this. Right? So I'm repeating the first two columns. And then you go like this. This times this times this. And that's positive. And you go this times this times this. Positive. This times this times this. Positive. And then the other way, this way, this times this times this, that's negative. That, negative. This times this times this, negative. And then that's it. So, like, let's go, right? I times uy vz. Kind of messy, right? I hat times uy vz. And then now this one. J hat times uz vy plus this one now. K hat times ux vy. And then let's go the other way. So now negative this way. J hat ux vz minus, not over here now, I hat uz vy, and then last one over here, this one, k hat uy vx. Okay, and then that's it. And you can gather like terms, right? I hat and I hat, you gather them together, but that's how you do it. Okay, so you kind of, if you like that way, that's one way. Another way is kind of what's called cofactor expansion, and it goes like this. So let's start with I hat. So you just kind of ignore that row and that column and look at what's left over here, and you multiply it kind of like a fish, like this times this minus this times this. So I go I hat and then this times this minus this times this. uy vz minus uz vy. Okay? And then now it's kind of tricky. You have to put a minus sign for j hat, So right here's J. You ignore that row and that column, and then just look at what's left over and multiply it like a fish, like this. But there's this minus sign over here, so just be careful. Okay, so uxvz minus uzvx. Okay, and then finally k hat, ignore that row, ignore that column, look at what's left, multiply it like a fish. Right, so plus k hat, this fish right here, uxvy minus uyvx. Okay, so whichever way you like better, do that way. Okay, let's try an example. Okay, so here's an application. Let's say I define some plane. Like say there's a plane formed by these 3 points, A and C and E. So they form a plane. Find me a unit vector normal to that plane. Okay, so the method is take any 2 vectors in that plane, doesn't matter which 2, and cross them. I guarantee you that cross product is normal to the plane. Right, like if you take AC and AE, so you go like vector AC cross vector AE, this is normal to this plane, right? Because AC cross AE, AC and AE form a plane. This cross product, I guarantee you, is normal to that plane. So let's take any 2 vectors. Cross them. Right, so let's say, how about vector from A to C? Right, so from A to C, 0 minus 0.5, 0.2 minus 0, 0 minus 0. Okay, and then let's go from A to E. Right, so 0.2 minus 0.5, 0.2 minus 0.5, 0.4 minus 0, and then negative 0.1 minus 0. Right, so then if we want some vector normal, I'll just call it n for normal. Just cross these 2 vectors, right? So you set up the determinant like this. And then this vector goes here, right? So, and then this vector goes here. Okay, and then you just do this determinant whichever way you prefer. I'm going to show you that fish way again. Okay, so in the I direction, this fish right here, 0.2 times negative 0.1 minus 0 times 0.4. Okay, and then minus j hat, this fish, negative 0.5 times negative 0.1 minus 0. Okay, and then k hat, this fish right here, negative 0.5 times 0.4 minus 0.2 times negative 0.3. Okay, and then that's the cross product. That's not yet a unit vector, right? So if we want a unit vector, just divide it by its own magnitude, right? No problem. I'd leave that to you. Okay. All right, thanks for listening. I'll see you on the next video.